Hi, and welcome to 6.3 Solving Linear Systems by Substitution. So this is going to be the third way we've looked at solving linear systems. The first way was by graphing, the second way was by addition, and this third way is going to be by substitution. You probably need to know if you were asked to solve it by graphing, which method you have to do. If you're asked to solve by addition, which method that is. And if you're asked to solve by substitution, which method that is. If you're just asked to solve the linear system, you could choose which one of those three you like best and approach it that way. It's probably also worth noting that I've done a bunch of demonstrations through Desmos to help you visualize that solving using graphing technology, like Desmos is also a very viable way to solve these. So if you haven't yet started using that to double check some of your solutions, it's probably worth practicing it. If you're asked to solve it in any way you want, you could go into Desmos and solve it. And that is something that in Pre-Calc 11 and 12, they actually do. So it's worth knowing how to do and how to visualize and see what's going on and use technology to help you solve problems. I don't discourage that, and I will try and ask questions in a manner on the quizzes so that I can tell that you know what each of them are. But if you're using Desmos to double check, then feel free to double check. So review and warm up substitution. So substitution just means we take a known variable or a known value and substitute into the equation. And I think the easiest way to explain this is to look at an example. So we have what is technically a linear system of two linear equations, x is equal to 3 and y is equal to 2/3 x plus 4. This is like an introductory warm-up problem. It's not quite the level that they're going to ask you in the workbook. But it'll help us just kind of get there. So this is telling us that x is equal to 3. So substitution just means that if I know what something is, and in this case I know that x is equal to 3, I can substitute it in, and instead of x, I can write 3. So if I do that, I'm going to do it in a different color. I can write y is equal to 2/3, and this is where instead of writing x, I'm going to write that 3 plus 4. And then I could go and I could simplify. 2/3 times 3 is 2 plus 4. And so then I have a value for y is equal to 6. And in our first linear equation, it actually gave me a value for x. So I have the point, if I can draw properly, 3, 4. And that would be the solution to this linear system. We can also do it this other way. I could take this, what is now a pink equation, and substitute it into this red equation. So I have, instead of y, I can write 6, and that's going to be equal to this rest of this red equation, 2x plus 7. So this is a substitution. Instead of y, I wrote 6, because I know that y is the same as 6. Now, this one is going to be a little bit harder to solve because we have this x is not isolated. So we're going to have to try and isolate it, try and get it all on its own. So I'm going to have to subtract 7 from both sides. A 6 minus 7 is a -1, and that's going to be equal to 2x. And I can divide both sides by 2. On the right-hand side, that cancels, and I'm left with x is equal to -1/2. That is not, of course, my final solution. I shouldn't be putting a box around that. My bad. My final solution is, of course, y is equal to 6, x equal to -1/2. So I have the point -1/2, 6. And that would be my final solution for this one. I should put some brackets around there. Did I do that on the first one? I did. Good. Okay, so this is where this is going to start to get a little bit more complicated and look a little bit more like the questions you are going to see in your workbook. Notice how, and if I do this one in pink again, my top one in pink, except I've kind of written over the bottom one. Let's try that again. My top one in pink, y is equal to x plus 6. It's not just a number, but instead of writing y, I can still write x plus 6. So I can take this and I can substitute it into my second equation. So I have my 4x plus 3. And instead of y, I am going to write x plus 6. And that's going to be equal to 4. And now I have quite a bit of algebra to do. And this is where, if you've been practicing your algebra skills, you're absolutely good to go. But if you haven't yet, it's going to come to a bit of a point, because not every single equation is going to look exactly the same. So now we really have to kind of critically understand what's happening with our algebra. So notice how we have x in two different places. So we can't just isolate x. We're going to have to somehow combine them. So I would recommend first simplifying. So to simplify, I can multiply my 3 into both of these terms, and I get a 4x plus 3x plus 18 is equal to 4. I can now continue to simplify by combining my like terms. I've got a 4x's and a 3x's. 4x plus 3x is 7x. Plus 18 is equal to 4. And now, since I have x in one place, I'm in a position to try and solve for x. I'm going to have to subtract 18 from both sides, and I end up with a 7x is equal to negative 14, and I can divide both sides by 7. So I'm left with an x is equal to negative 2. I now have an x value, and I can choose to substitute that into either one of these to get my y value. So I'm going to put it into this pink one, so I'll do it in pink. I get a y is equal to negative 2 plus 6. Y is equal to negative 2 plus 6 is 4. So my final solution is negative 2, 4. So notice how that second step, where I found one of the values and then I go back in and I substitute it in one of the original equations, is exactly the same as the addition method that we did in the previous chapter. So it's really only the first half that looks a little bit different. Let's look at a couple more complicated examples and talk about the process in general a little bit. So the process is solve one of the equations for one of the variables. In all of the previous examples I did, that one was already done for you. 2, substitute it into the other equation, which is what we did. And notice how we've got that keyword here, substitute. Solve for the unknown, and then substitute that back into the original equation. And then you can do a double check. So 3, 4, and 5, we've already done those steps in all of the previous methods that we've gone over. So let's look at these. I might have crowded myself a bit too much here. I'm going to move this one down a bit. Give myself a little bit more space. 2x plus y is equal to 4. 3x plus 4y is equal to 1. So we can choose either of the equations, and we can choose what variable I want to solve it for. I think in this case, since it's a single y, 2x plus y is equal to 4, it'd be easiest to solve for y. It's not necessarily the right way or the only right way. It's just one option. So if I take this equation and I look at my 2x plus y is equal to 4, and I solve it for y, I can subtract 2x from both sides, and I'm left with y is equal to 4 minus 2x. And this is step 1. Step 2 is I'm then going to substitute it into this second equation. So I'm going to take my y and I'm going to substitute it in. So this will look like my 3x plus 4. And instead of y, I'm going to write 4 minus 2x. And that's equal to 1. I'm going to have to simplify. 3x plus, I think that's a 16 minus 8x is equal to 1. Combine my like terms. I have a positive 3x and a negative 8x. So I think that's a 5x, a negative 5x plus 16 is equal to 1. And if I subtract 16 from both sides, I get a negative 5x is equal to negative 15. Divide both sides by negative 5. And I get an x is equal to 3. I'm then going to take my x is equal to 3. And the easiest equation now to substitute it back into is this one. because it already says y equals the algebra is already done. So I'm going to take it and I'm going to do this next step in pink. This was step 3, by the way. Keep track. That was step 3. Let's do step 4 in purple. Y is equal to 4 minus 2 times 3. So if I plug that into a calculator or do it in my head, 2 times 3 is 6. 4 minus 6, I think, is at negative 2. And this would be step 4. I now have my final solution. I now have my x value of 3, my y value of negative 2, brackets, final solution. And I'm running out of a bit of space here to do the double check, but I could take this value and I could substitute it in to both of my original equations, and if it works, then that's my double check. B, 2x minus 4y is equal to 7, and negative x plus 8y is equal to negative 5. I'm not necessarily going to choose the easiest way this time. I'm just going to be like, all right, this one is first. I'm just going to solve for this one. So I'm going to solve the first equation for x. So step 1, which I will do in blue again. I'm just going to put a circle. Well, that was the wrong color. Let's try that again so it doesn't get confused with the rest of this. 4. Let's start with blue again. I'm going to solve for x. So I am going to add 4y to both sides. And I get a 2x. Negative 4y plus 4y is 0. Is equal to 7 plus 4y. And then I'm going to divide by 2. And I'm going to divide everything by 2. So I get left with x is equal to either 7 halves or 3.5. It's up to you. Plus a 4 divided by 2 is 2. 2y's. So again, this was step 1. We're going to do step 2. I'm going to substitute it into the other equation. I've got a negative, and instead of x, I'm going to write this equation, 3.5 plus 2y plus 8y is equal to minus 5. I'm going to have to multiply this negative sign into both terms. I have a negative 3.5 now, minus 2y plus 8y is equal to negative 5. Minus 3.5, I have a negative 2y plus 8y. Negative 2 plus 8 is going to be a 6y is equal to negative 5. And now we're writing this as a decimal. I'm really wishing I'd written it as a fraction. But I'll commit to it and just keep going. I'm going to add 3.5 to both sides. So I'm left with 6y, a negative 5 plus 3.5. Most people might need to plug this into their calculator. And again, I highly recommend you pause this as you're watching it and practice plugging things into your calculator. I get a negative 1.5, and I can now divide both sides by 6. And I get y is equal to negative 1.5 divided by 6. Which is y is equal to negative, get rid of that y, I was crowding it, negative 0.25, or if you want it as a fraction, which I might use because I like fractions better, is a quarter. Oh, I'm definitely going to use that as a fraction. And that all is step 2. Oh, sorry, I lied about that all being step 2. This is step 2, and the rest of it is step 3. So I'm going to substitute that back in. I'm going to take let's use pink. I'm going to take this quarter and I'm going to substitute it into the other equation. So I have a negative x. Oh, we talked about putting it into this equation because it's already solved for x, didn't we? Let's do that. x is equal to, any one of them work. They're all mathematically appropriate, but sometimes some ways is going to be easier. I've got a 3.5 plus 2. Instead of writing y, I'm going to write a quarter. X is equal to 3.5 plus 2 times a quarter is, I believe, a half, which means that x is equal to 4. So my final solution is then going to be my y value, which is a quarter, and my x value, which is 4. So I end up with 4 and a quarter. I have obviously taken up a little bit more space than I meant to, so I'm going to take this out. I'm going to try, just give me a moment, to, we're going to copy it out, and I am going to add another page so that we can do this one over here with as much space as we want. Yes, I think this was example C, maybe. There we go. Again, choose any variable that you want to solve for. It doesn't particularly matter which. I think the one that's by itself is usually going to be the easiest. So in this case, I will do it for, oh no, now I've lost my pen because I reattached my keyboard. There, it's back now. Cool. Or is it? I'm going to solve this one for y. So step 1, solve for an unknown. Let's do that in blue again. So if I have this 3x minus y is equal to 5, I'm really enjoying having tons more space. Should probably take a note about that. Don't crowd your work. Give yourself enough space to do it. I'm going to solve this for y. I'm going to minus subtract 3x from both sides. 3x from both sides. I end up with a negative y is equal to 5 minus 3x. To get rid of that negative sign, I'm going to multiply everything by negative 1. I get my y is equal to a negative 5 plus 3x. I am then going to substitute it into the other equation. You cannot substitute it into the same equation. You'll end up with pretty much the same thing. So I have a negative 6x. I just about did the mistake I talked about. Negative 6x plus 2 times my y value, which is negative 5 plus 3x. And that's going to be equal to 5. So now I have to simplify. Negative 6x, my 2 times negative 5 is a negative 10. 2 times 3x is a 6x, and that's equal to 5. My negative 6x plus 6x is 0. So I end up with a negative 10 is equal to 5. And I'm a little bit stumped now, unless I remember that there's actually 3 potential outcomes. So normally, if we have sort of our normal 2 lines, those are kind of 2 normal lines on an axis, they would cross at a single place. However, in some instances, they could be, if I do another little sketch with the same sort of colors, I've got my green, they could be parallel as well. If they're parallel, there will be no solution. So in this case, negative 10 will never be equal to 5, so there are no solutions to that one. And I am done. Again, these are a bit more complex and take a little bit more space. Feel free to take your time, do them carefully. Oh, I'm ending up with some exciting things. Do them carefully and show all of your work. It's no longer for me that you show all your work. It really is, in fact, for you.
Thank you for watching, and I just wanted to remind you guys a couple of keys for success. Number one, you got to do the practice questions. If the things I'm saying make sense, that's phenomenal, but you still have to practice and make some mistakes on your own. And that goes along with number two. If you get stuck, ask me questions, get in touch, write me an email, make an appointment, or leave a comment on the YouTube video. And step number three to success is look after yourself. Eat good food, get some exercise every day, and socialize as much as you can right now. I hope you guys are all doing well, and I will talk to you soon.